Today on the bench I have this VHF FM marine radio telephone. It's an Amcom AM88i, and this marine VHF radio was installed in our family sailing boat before years ago, many years ago. I remember using this radio, and I was still a kid. So back in those days, the mobile phone was not really developed yet. So when you are out in the sea sailing, you would have well, still today, but I remember back in those days, you would use this radio as a telephone as well. Hence the name Radiotepelephone. Yeah, I remember from out in the sea. Remember us calling our relatives. First of all, making the call on channel 16 to the coastal radio station, which is more next to us, which in our case, from the harbor we were, the coastal station was about 50 kilometers away. And yeah, then you tell them, they will give you a channel to go talk to, different from the 16, the calling channel and emergency channel. And then you would ask them to call the number you provide. And then they will make the phone call happen. And obviously, when you talk to the radio and you push the PTT, you cannot hear them. So it's not duplex communication. So you talk, and then when you release, you can hear them. You have to instruct the other people on the other side on the phone to know that. But anyway, it was a lot of fun. I remember those days with have good memories of those days. It was kind of fun. Today, obviously, everything is much easier with the phone, but still, when you are out on the sea, the mobile phone wouldn't work when you are far from the coast. Anyway, then we sold the sailing boat, and I thought I would keep this radio with me, as I was already into radios. And now it is. The antenna used with this radio was just a simple vertical antenna at the top of the mast, and it was probably 1 meter long, something like that, with a loading coil at the base. I still have the antenna as well, not here. Anyway, the radio is in good shape. It got a nice clear audio out of the speaker, and it's got this flat keypad, which gave some troubles at some point, but looks like it's working now. So let's see how the radio works. It's pretty simple actually, and how it performs after so many years. So I have hooked up the radio to this switching power supply, and the power supply is providing 13.8 volts. Some modification I want to do is to put a fuse in the line, which is not there now. I had to make a connection to extend the power cable. And let's switch it on. Okay, now the radio. Let me get the audio out of the speaker. I'll switch it on again. Usually, the radio, when you switch it on, it emits a beep. There you go. Not all the time. Don't know why. But anyway, that's the beep that goes with the keypad as well. So you've got just two knobs: volume and squelch. Pretty easy. Microphone is on the side. It's a little bit corroded here, but nothing major. It's like bayonet. You unscrew this just a few degrees, and then you can take it out. This is the connector. It's 5 pins, and on the side, obviously you've got holes for a bracket. This is the shape of the radio, by the way. Okay, so it's facing upwards, and it's convenient actually. From the place we had this radio installed, it was really convenient to have the front panel this way. Unfortunately, this got broken over the years. This rubber part, which is reinforcing, you know. So I think I will just get rid of it, because there's no way I can fix this. This is the microphone, Regency Polaris. Somewhere I could have a manual or something. Not sure. Looking at the back, we've got the antenna connector, which is a PL SO239. So I just put, not taking out this now, but just put this adapter for BNC, just for quick release of the cable. There's like an external speaker jack and the DC supply jack. This is made in USA, by the way, Indianapolis, Regency Electronic. I haven't seen many of those radios, but I have seen one once. And this is the DC supply connector. So let's put it back in. Let's connect the antenna. Let's crank it on again. Okay, so the microphone, and let's try to send a signal to the radio from the Marconi, modulated at 1 kilohertz in FM with 2.5 kilohertz deviation. Let's start with that, and then we see. So I think, because the channel spacing should be 20, well, normally between one channel and the next one is 50 kilohertz, but also the channels are arranged in a way that you've got two not adjacent channels which are just 25 kilohertz apart. In other words, let's say this is the 16, this will be the 17, but 50 kilohertz away, so this is 50 kilohertz. But in the middle, there might be another channel, which is, I don't know, let's say, I don't know, 70. The channels are a bit weird, as they are arranged. And they go from channel 1. Unfortunately, there's not a channel knob on this radio, which make it difficult. There's not scan. There's just, as you can see, the functions here are just a quick go back to channel 16, a dual watch. If you are on any other channel, you push dual watch, and the radio will monitor the channel 16 continuously. Obviously, if there's a transmission on 16, that will stop. For example, let's try that. If I set a signal on 16 now, we should have a stop. Yes, so receive. It's channel 16. Just give a second. Okay, so there you go. I'm sending now a signal and it stopped. Okay, like any normal dual watch. And then when the signal drops, it will start again working the dual watch. And you take it off. Private channels. It must be something software, because normally it doesn't work. Normally it doesn't work, but for some reason, sometimes it works. And you can, and as you, it's not working now, but sometimes it works. I don't know why, but you push this button and you get a P here instead of the 0, and then you can choose P1, P2 or P3. That corresponds to 3 frequencies. One of those 3 is simplex and the other 2 are duplex, and those are not in the normal channel arrangement for these VHF radios. So that's why they're called private channels, but probably it's not made for this the market it was intended to, like Europe, I would say. Then you've got one 25 watt power switch for the output power. Normally is 25 watts. As you push the button, you got the light on the 1 watt. That means that the radio is transmitting low power. Obviously the keypad and dim and bright. And if I switch off the light, first of all you see that the keypad is backlit. Unfortunately, it's a bit scratched or broken. But anyway, I don't even know how that happened. But anyway, this is full brightness, and as you push the button, you can reduce down to 0 and go back up. As you can see, you can just push. You don't have to keep pushing. You can keep pushing and it will just go up and down like a potentiometer. Okay, that's handy when you are in a dark environment. It's pretty handy to lower the brightness, because it's not easy to understand through the phone camera, but it's pretty bright. And yeah, the audio is pretty loud, very loud, very loud. And obviously when you are in a sailing boat and you are outside of the boat and the radio is inside indoor, you want to have the volume cranked up so you can hear if somebody calls you. There is some noise coming from the volume, as you have heard, so that will be something to have a look to. There you go. Do you see this private channel light? I don't know, for whatever reason, sometimes it lights up, it comes on. Anyway, I'm not able to push it now, but probably at some point we will be able. We will check. So yeah, let's send a signal from the generator. Let's see how is at least the sensitivity of the radio. Okay, I'm sending a carrier at 156.8 megahertz, which is channel 16. The level is -73, which is usually S9 on HF. Don't remember what would be an S9 on VHF, probably a bit different, but nevertheless it's a good signal. Modulated 1 kHz, 2.5 kHz deviation, and let's listen to it through the radio. Okay, so the radio is receiving, definitely. Let's try to change the deviation. Okay, now I am modulating in FM at 5 kHz deviation, which is quite wide for a VHF FM radio. But I believe this kind of radio is wider than normal radios for amateur use. Yeah, so we might connect the speaker jack to the Marconi and have then the audio to come back into the AF input to analyze the audio. So if we I don't have any spec, unfortunately. I might have a look on internet to see if I can find something. But to start with, 2.5 kHz deviation, carrier modulated 1 kHz, and we can hear now from the Marconi speaker, and let's have a look at there you go. Something was not working properly with the volume as usual. I'm cranking the volume up. We are now inputting a level of 400 millivolts thereabout, and we can hear the tone very well through the Marconi, and we can now lower the as usual, lower the level of the carrier and keep an eye on the synod meter, and look for the 12 dB range. Sorry about that, I had some squelch. I turned down the squelch so we can hear the a signal into the noise. We crank up a bit the volume again. Okay. And yeah, so we wanna look for 12 dB synod once again, which is this line here. We can also see the number here. We are now listening to the radio with no filter, with no audio filters. Okay. And there's a bit of oscillation, but we are about there. And we are minus 110.7, which is 0.65 microvolts. So it's not very sensitive, actually. I think if we compare that radio with a normal 2-meter VHF FM amateur radio transceiver, we would have a better figure. But anyway, that's what we have for now. Maybe it can be tweaked a bit to improve sensitivity. Alright, let's have a look now on the transmitter side. Okay, we are now in transmitter test, same channel 16. I'm trying now with low power, should be 1 watt, and let's see what we get. The power will appear here. I put a 10 kilohertz IF bandwidth filter, and yeah, let's have a look. Let me reduce spectrum analyzer. First of all, we see that the carrier is a bit low, 700 hertz low. Okay, and the power is 1.87 watts. Okay, and we can hear the voice through the microphone and through the speaker of the Marconi. Test, 1, 2. It's pretty loud. It's pretty clear, crystal clear as well. Very crystal clear. I love that modulation. I like that modulation. Right, so let's give it a go with 25 watts, i.e. full power. And by the way, 1 watt in receive mode, the radio is absorbing about 650 milliamps. On 1 watt is absorbing 2 amps. And let's see full power. We are at about 4.8 amps. And the power 21.7. Okay, they're about, so not just 25, not quite 25, but close enough. That's not a big difference anyway, but maybe that might be also something else to have a look to. And if we look at the spectrum, there you go, still the same 700 hertz. Test, 1, 2, 1, 2. Okay, that's the transmitter test. Now let's crack it open and have a look inside. So open this radio. On the bottom side, there's well, actually there are no screws anywhere. So I believe, I've opened the radio already, so I'm pretty sure that we have to remove those white caps, and there must be, we should be able to find the screws. There you go. These cups are getting old and they are kind of cracking as I try to remove them. We are, there you go, this just cracked. We're talking about a radio, which is probably, I was a kid, so I'm 41. It is at least 35 years old. Okay. So that's kind of normal. Unfortunately. There you go, you've got the 5 caps removed. Now we need a screwdriver. Let's start with this one. Yeah, you don't need to see all this part, so just remove the screws and open the covers. Okay, I have the covers removed, And what I've found is this is the top cover with the big speaker. I cannot see characteristics. It looks like it says Korea. Anyway, the cone, interestingly, the cone is transparent. And yeah, inside of this cover it's got this coating. The bottom cover instead has got some rust, which is coming from the metal down there at the back, which got rusty over the years. Yeah, this is the bottom part. So maybe we can try and clean this panel. Then there is the frontal panel is kept in place by these screws. And by the way, those screws are not normal screws, but these are like the others are Torx. There are some fancy flap cables. I think I did this, pretty sure, in the past, just to be able to disconnect the cover away. And there's something here in the DC supply line. It looks like some sort of component across there. I don't know. I'm not sure why it's there. I should know first which kind of component it is. Usually here we find something to prevent the polarity inversion, no? Even though, as you can see, you cannot really invert because the plug is one way only. This is the board. This is the antenna connector. There's some caps there. Some adjustments under the shield. This shield, oh, there's a big chunk of aluminum here, which probably is kept with these screws. It's probably for, well, for sure, it's for heat dissipation. That make me think that PA section is here somewhere. And yeah, some other trimmers, some quartz. Oh, there's a board here in vertical. There's a coax going into this board. Interesting. This coax here. I want to try to look for a manual for this radio. Maybe I'm lucky. Not sure actually. And another heat sink there, fancy shape. Another train cap. And we can look also on the back side of the front panel. There's another shielding here. And yeah, and then I will remove the front panel as well. Let me take a look. I've taken the bottom shielding off is this one here. Obviously these two screws are very rusty. I'm gonna get rid of those and put new screws. Unfortunately, the rust made it to this piece of metal and also this piece here. Not sure if I can improve this situation, but I will try. Here we can see two transistors which are screwed in to that big piece of metal for heat dissipation, and are MRF 260 and MRF 264 by Motorola. It looks like these two screws, which keep the transistor in place, it looks like they are somebody not in the factory ruined the screws. But it looks strange to me because my dad bought this radio new, and that's pretty strange. Unless the radio got damaged in the finals, and it went to repairing. Not sure. Anyway, doesn't really matter. This is the whole board on the bottom side. It looks like all the solder. There's another adjustment in there. Another two in the holes. It would definitely be handy to have the manual for this radio, but I'm not sure if I will find it. I'll give it a try now. Try to have a look. You have the front panel removed. It was just connecting to the main board with this 3 flat cables. It looks like this cable is a little bit damaged, so the contact could be compromised, but I think it shouldn't be a problem. It should be okay. Even if I cut out a little strip, it should be okay. And this goes into this socket there. And then there's this one, which is kind of bent, but I have checked on the bottom side and is well soldered in place. There are some cables going around, so as you can see, so probably I'll just see if it's securely in place, if there's no issue with the soldering. Obviously there's no issue because it was working, but yeah, I'll have a look if I can improve a little bit, not to have problem in the future. And this is the frontal part of the radio with some coils. There's a trimmer quartz. Maybe this is a frequency adjustment. This quartz looks like an 11 meg. Yeah. And also want to take the front panel apart and have a look at this potentiometer. This is very scratchy. It must be clean. So probably it's just 4 screws. Well, actually 6 screws. We take this plus this one here in the middle. And there's another one here, but it comes from the back. So probably just undoing this 6 in the perimeter, this will come off. Let's have a look. Oh, and looking around, I found this pot with all those jumpers. As you can see, there are 2, 304, 305, which are still in place, and the other ones are all cut. So that must be for setting up the market configuration, depending on the market the radio is going to. But I don't know the combinations. And also looking around, I found this little hair. Looks like it's obviously metallic. I'm gonna remove it now. Just in here. This one here. Anyway, just to avoid it creates any short inside. Okay, I've got the front panel opened. I'm on the volume pot. It's a 10K pot. I have sprayed already, as you can see. It's a 10K pot. I have sprayed already some spray for contacts, trying to get into the pot, trying to get the spray into the pot from the holes, because I wanted to see if I can fix it like that without removing and opening the actual pot. I'm not sure, but according to the meter, according to the sorry for the reflection, according to the bar graph, it's smooth. It looks smooth. Now, according to the bar graph, it's quite smooth, but it's difficult to say. You know, I don't see big jumps, that's for sure, but it's difficult to say. But I'll try this way. I'll try to spray and move it up and down and see if this is the second half of the volume. Let's see the first bit. It's not very stable, but That might be because it's in circuit. Yeah, I'll try this way. Try to give him more spray and move it up and down, and then we will see. Otherwise I'll have to take it apart. Okay, I have now cleaned the pot and tried it, and it looks like it works fairly well. The thing is, the keyboard now is not working, or actually it's working partially. And I believe that the problem is on this flat cable, which as you can see on the edge is missing some bits, and it's not making good contact on the socket. So because it's damaged, this part, I think I will cut out a little strip, and it should work. So hopefully, fingers crossed, because this keyboard is a pain in the ass. Okay, I have cut away this little bits of the flat cable, and hopefully now we'll make a good contact. Fingers crossed. Let's give it a try. Okay, let's give it a check for continuity first. It's difficult to have the right shot, the light and everything. Okay. Looking good. Looking good. Okay. Come on, just the last two. Okay. Actually, I see better through the camera than with my eyes. Believe it or not. So I'm gonna check again through the camera. There you go. Just to be sure, I'm not shorting the two test lids. Okay, so looks like all are making good contact there, and let's have a look at the keypad. All right, moment of truth. Here's some power. Let's crank it on. I got a speaker connected. We need the microphone. So I'm gonna check the also the pot that I've cleaned. All right, let's open the squelch. It looks okay. It looks okay. It could be okay. Okay. Now the moment of truth for the keyboard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay, channel 16. Dual watch. Private channels, which is beeping anyway. Power and dim. Okay, the keyboard is working. I'm glad, and yeah, let's continue on. Okay, now what I'm doing here is I'm trying to see if that trim cap is the one to correct the frequency, which I believe it is. But I'm not sure. I don't have the schematic. So what I'll do is the radio is on. I will transmit into the Marconi and observe the offset, which now is. Let me get into TX. I'm trying to squeeze the microphone because I only have two hands. I have to keep the. Okay, now I'm squeezing the microphone with my legs, and I'm getting 700, about 700 offset. So what I'll try to do is I will direct some warm air towards the quartz area and see if the frequency will move. So I'll reposition the phone, looking at the Marconi screen. Okay, so I'm going on TX now, and I'll take the hot air again. And I will point some warm air towards the quartz. And yes, as you can see, the frequency is moving quite a bit. So, of course, it's getting warm, and we are now going 1.3 kilohertz of drift. Well, actually, we had 700 kilos of drift. So, yeah, I'm pretty sure that if I now will let the quartz settle down in temperature, then I can adjust the frequency from there. Okay, now I'm ready now. So once again, we go on TX. Just take the volume down. Let me take the volume down just a second. Okay. So what's the offset there? 640. Let's see if we can adjust this. The other way. There we go, pretty close. Pretty close, huh? 8 hertz. It's pretty much okay. Very good, and as I talk, it moves a little bit, but it's fine. Perfect. Great. That's another step done. Okay, it's been a bit difficult to find any information about this radio. Actually, I didn't find any information. So the only things that I've done are I've opened the microphone because there was a bad contact on the PTT, which is now solved. Just a bit of spray on the PTT contact, and yeah. So far we have adjusted the reference frequency, the flat cable for the keypad, the PTT mic, and maybe I will try now to clean the rusty parts. And I have seen somewhere a method to clean these plastics, these white plastics, which get yellowish with age, and maybe I'll look for this method and see if I can bring him back to a nice and shiny white. Other than that, I might pause this radio for now and put it aside because I want to see if I can find any schematic, any manual. That would be great. Let's see, Regency Polaris is here. Here I see Japan. So I'm not sure where it's manufactured, but Regency Polaris is reported as being in Indiana. So I have a friend in US. Maybe he will be able to find some informations for me on this radio. If any of you that's watching this video has a schematic or service manual for this radio, please contact me via the email. The last thing I'm doing here is trying to remove this rust on the chassis. This oxidization on this metal piece is, and I have also cleaned the frontal panel. As you can see, it's now nice and clean, and also I have cleaned also all this white plastics, just normal cleaning. I have taken apart the internal speaker, which appears to be splash proof, and a bit of cleaning to the speakers was very dusty, and also the bottom cover, which yeah, was a bit dirty and scratched, just marks, actually, not really scratches, just marks that I was able to clean for the most part. Yeah, this is the rust. Still, it's a bit difficult to get into the corners, but I have cleaned the most of it. And the last bit is the metal cover, which goes over here, that got rusty as well because it was in contact. And the two screws, I believe I'll get two new ones, but maybe I can try clean them as well. So I'll show you what I'm doing for rust cleaning. I'm using a solution with things I have at home. Just 3 things. I used salt. I have used lemon juice, and to finish and give it a bit of volume to the solution, I added some vinegar. And then with this sponge, well, it settled there for a while. I let it there, and then with this sponge I was able to clean it up, basically, because if you look here, this was all rusty, and on this side as well. So now I'm trying to clean this final bit. I put in the 2 screws. Try to put the microphone parts, and then I have to go on the radio chassis, but I'll have to I cannot plunge the radio chassis in here, so I'll use something and very patiently try to see and remove the most I can. I'm taking the microphone apart now. Just 3 screws. I also have removed this rubber bit that was broken. So it's just 3 screws, and this should come off. There you go. There is a piece of metal, which makes it kind of heavy. With this sponge pushing on the microphone capsule. That's the capsule, quite big. Must be inside, but anyway, it's a big capsule. Yeah, there's a PTT. This is the PTT contact which I've got already cleaned, and this is the metal piece which I want to clean a little bit, just to, as you can see inside, it's nice and shiny. Good construction anyway. There is some attention to details there. Yeah, so this black part is held in place with those 4 screws, obviously. So I'll try to desolder the wires, and oh, there's a red wire there, not connected. Yeah, I'll desolder the wires and get this spring out to go into the bath. Okay, so I have taken the microphone apart, and yeah, this is the piece, the spring that will go into the solution for cleaning. And look at this capsule. It's probably made in Japan. There's this Velcro filter on top of it. It's a nice big capsule. Very nice. Maybe can be used as a speaker as well. And maybe that's why there was this red wire not connected. Okay, I'll try to take this as well, the connector, because it's a bit oxidized here. And look how nice this connector is. So you remove one screw, just one screw, which goes in here. Then you slide the connector back, and it's a neat connector. Very nice. Good. So I don't want to desolder the connector because it's very nicely done. So I'll try and put this bit into the bath one part at a time, giving it time and then rotating it until I get it a bit cleaner. I have now cleaned this shielding plate. Oh, at least cleaned from the rust. So there's no rust anymore here on the edge, and I wanted to be sure. I have removed the rust from here as well, from the chassis. I wanted to be sure that there was no rust hidden behind this plastic adhesive. So I just cut off a small portion of it, just to be able to have a look under and see the chassis. The chassis looks clean, so now it's not going to be in the marina environment anymore, so should be okay for years to come. Okay, I'll put the shielding back on like this. Close the radio, and maybe I will finish the cleaning of this, but I'm not sure what is creating these but I didn't find the right product yet to clean it. So clean it now and then put it back on, and then close the radio and have a look once again how it goes. Also, I have to reinstall the microphone, close the microphone. I have cleaned this as well. It's not as I would like it to be, but it's okay. I think I don't have the right product, most likely. This is also better now. Probably here. Probably you can't see it here, but the material is it's been attacked. It's full of small, very tiny holes. Let me see if I can zoom in. So probably I think I cannot do better than this. It's only on one side, by the way. Yeah. But for the rest is clean. So I'll put the microphone back together and close everything. Okay, the radio is closed again, and I'm running some more tests on it. I've got opened the microphone connector so I can put the radio on TX, shorting these two pins like this. And I'm also injecting an audio signal from the function generator, and I'm running some tests on low power because I'm on PTT I'm on TX for a bit of time there. So what I send from the function gen is a sweeping tone, a sine wave, sweeping from 100 Hertz up to 10 kilohertz with a 4-second sweep in a linear fashion, and I want to look at the Marconi under the different analysis it can do. So first of all, let's start the sweep, and let's see if I go on transmit now. We should see the let me see, the level is 5 millivolts, the level of the generated tone. If I go on transmit now, we should see. Yeah, we see the bar chart is changing because it's a sweep, so it's not uniform. It's also changing. Let me get the hold range, 10 kilohertz. So what we get. As you can see, the deviation is going up and down, but basically is there a range hold? No. I thought there would be a range peak hold here as well, but maybe I'm wrong. Yeah, max hold, there you go, on hold ranges. So on auto range, sorry. So go max hold. Let's see what we get. And so we get the 2 watts on the left column, which is the output power. And we get also the FM deviation, which reaches almost 6 kilohertz of deviation in the peak. So if we have a look now to the let me reposition the camera. Okay. So if I go on TX once again, and I send the 1 kilohertz tone, you can hear the tone. We see the FM deviation. Now, if I sweep, that will be the sweep. We can have a look at the spectrum first. So this is the 1 kilohertz modulating in FM. Okay. If I switch it off, we are left with the carrier. Switch it on, we have the 1 kilohertz FM modulated signal, modulated carrier. But more interesting would be the we look at the scope. So this is the 1 kilohertz tone demodulated. And we can see that we've got on a vertical scale, we've got once again the deviation. So we've got 8 kilohertz maximum, so we've got 2, 4, 6, 8, so we are reaching 5. And if I sweep, we see also the intensity changing, the amplitude changing up and down as it goes up in frequency. And we can see this better on the modulation analyzer window, where we can activate. We've got 10 kilohertz span, the reference at 5, so from 0 to 10. Top of the gradicle is 10 kilohertz deviation. And we can activate the max hold function and let it sweep, and we will get the shape of the transmitter, showing the audio response, frequency response. And if we get the markers now, we see that we reach the top. We reach the top here, marker 1, at about 5 kilohertz as expected. We get the volume down, and yeah, we can see that below 1 kilohertz we've got this steep roll-off. So at 1 kilohertz we are already at maximum, producing the maximum deviation. Then we got this roll-off on the lower frequencies, and on the higher frequencies we have, if we move the marker to, for example, at 5 kilohertz, audio frequency, we've got still 1.24 kilohertz of deviation. So it's still modulated up there, and it rolls off down to 8 and 9 kilohertz. So that's why we have this crisp and clear audio from this radio. Okay, we have a look at 3 dB point. What about here? Let's move the other marker, going back to 0. What about here? Okay, so we've got this we've got this delta frequency between the two markers of 2.54 kilohertz of bandwidth, let me say. Okay, and this is a nice analysis. Another nice feature that I just noticed from this Marconi is that actually, if you want to do this, you can. You don't need an external generator like the one we're sweeping now, because you just use this AF sweep function and activate the max hold once again. So if I do that, obviously I move the cable onto the AF gen output of the Marconi, and it will use the second AF generator, because this one has got 3 generators. We'll use the second one. So you want to check, TX test. So you want to check, and generator number 2, you want to check the level. So let's put the level at 5 millivolts like previously set. And now if we expand, if we activate the AF sweep, it will automatically activate the max hold function as well, and it will sweep, but it's not a continuous sweep like my function generator. It's sweeping in steps, and is arranged in a way that basically the sweep time of the AF gen and the sweep time of this window, they are sweeping at the different frequencies in order to get the graph in the end. So I can rise up the volume. You see, it takes maybe a bit longer, but eventually you get there. You got the same result, as you can see. And the sweep function will sweep from 0 to 20 kilohertz maximum, and or according to the span you have in the window. So if I reduce the span to 500 hertz instead of 1 kilohertz, that will be from 2.5 to 7.5. So the AF will generator will sweep only inside inside that window. But the maximum sweep frequency will be up to 20 kilohertz, which is more than enough for audio purposes. And here we are getting there with the results. Okay, it looks nice as well as before. Just takes a bit of time, but it's a nice feature, nice function to have. And there we go.
Navigational assistance and traffic organization services only for la speculative way of transiting ships to wire sign of an ad.
Marina Nord, La Spezia, Costa Vulcan, numero 854, 6, 15, novembre 2022, rilancio, numero 7, Mar Ligure, La Spezia, VTS, La Spezia, assicura i servizi di assistenza alla navigazione e organizzazione.
Southwesterly, C4, westerly, 2, C3, Sicily, straight, southerly, 1, C3, southerly, 4, C3, southwesterly, 5, C, firm, southwesterly, 4, C, firm, southern, Joliet, C, southwesterly, 4, C3, southwesterly, 4, C3, southerly, 4, C3, southerly, 4, C3, northern, Joliet, C, southwesterly, 5, C4, westerly, 3, C3, southerly, 6, C4, southerly, 5, C4, Adriatic, C, southwesterly, 5, C4, northeasterly, 2, C3, southerly, 6, C4, southerly, 5, C4, central, Adriatic, C, northwesterly, 5, C4, southeasterly, 3, C3, southerly, 5, C4, southerly, 4, C, northern, Adriatic, C, northwesterly, westerly, 5, C4, northwesterly, 2, C3,
A. Meteormare, in bollettini, cielo, tempo, sul Mediterraneo, immenso, sole, 18, 0, 11, 6, giorno, martedì, 13 dicembre, da 22 e 4, fino alle 06, 00, 11 di domani, 1, avviso. Centro, nord, longitudine 9 gradi, est, latitudine 44 gradi, 04, nord, longitudine 9 gradi, est, latitudine 44 gradi, 04, nord, longitudine 9 gradi, est, latitudine 44 gradi, 04, nord, longitudine 9 gradi, est, da 24 ottobre 2022. Dal lunedì al venerdì, dalle 06:30 UTC alle 14:00 UTC e martedì e giovedì dalle 17:00 UTC alle 23:00 UTC. È pericolosa la navigazione sosta, pesca, ancoraggio e qualsiasi attività di superficie, subacquee per esercitazioni, subacquee militari, navi e natanti in transito, prestino, massima, attenzione, fine, avurne.
Marina, North, La, Spezia, Coastal.